We bought this Ankara flat with a hallway that howled like a wind tunnel. The developer had thrown up a decorative partition, single-layer plasterboard on flimsy metal studs, hollow as a drum. Zero storage, zero sound isolation, every footstep echoing. We could have demolished it in an afternoon. But then we measured the structural studs, 600 millimeters on center. That's the exact mounting width of a standard 19-inch rack frame. The universe practically handed us the solution. Most people see 19-inch racks and think server rooms, garages, industrial ugliness. But the EIA 310 standard gives you a precise hole pattern every 15. 875 millimeters, infinitely adjustable shelf heights without drilling a single new hole. Cold-rolled steel uprights rated for hundreds of kilos each, yet a 6U frame weighs just 3 kilos. 6 stacked floor to ceiling, 14 kilos total. A Billy bookcase empty weighs 30. That difference mattered because our floor joists are shallow. We ordered 6 custom frames at 400 millimeters each. 6 times 400, 2,400 millimeters, matching our slab-to-slab height, minus 3 millimeters for expansion. Each frame is 12U, 72U total of vertical adjustability across the whole wall. Flat-packed with M6 cage nuts. We spent an evening counting threads because the standard calls for 12-24 threads per inch, but cheap imports use M6 metric, which strips under load. We verified every frame with a thread gauge before signing for delivery. First frame went up on a Tuesday. We thought we were clever using the existing stud anchors. Stepped back and the top flange leaned 4 millimeters toward the living room over 4 meters. 4 millimeters sounds like nothing. At eye level, it screams amateur. The lean came from the hallway floor, sloping 3 millimeters over the frame width, plus a 1 millimeter twist in the bottom flange from manufacturing tolerance. We took it down, started over with a laser level and a box of stainless steel shims. Fixed the lean by shimming each frame base in 0, 5 millimeter increments until the laser showed perfect plumb within half a millimeter over the full height. Between each frame, we inserted a 12 millimeter closed-cell polyethylene foam strip cut to the flange profile. Does 3 things. Isolates vibration from footfalls, prevents galvanic corrosion between the black oxide steel and aluminum shelf rails we added later, and compresses just enough to lock the stack together when we torque the through bolts to 12 Newton meters. Structural attachment meant drilling through the rack flange into the structural studs behind the original plasterboard, 12 millimeter lag bolts with washers every 600 millimeters vertically. Hit a snag on frame 3. The stud had a notch for an electrical conduit. We bridged that frame with a horizontal steel angle bolted to the adjacent studs, transferring the load around the obstacle. The engineer in me slept better knowing the load path stays continuous even with real-world framing imperfections. Cable management became a vertical raceway built into the rack itself. The EIA standard leaves a 100 millimeter gap between front and rear flanges on a 4-post frame, but we used 2-post frames. Added a rear cable tray from perforated steel channel bolted to the rear flange holes. Hides the router, fiber termination, and HDMI over Ethernet balance for the living room TV while keeping bend radii above 30 millimeters for fiber and 50 for copper. No more dust bunnies on power strips. Skinning the steel skeleton meant building MDF boxes that slip over each frame like a sleeve. MDF machines cleanly, takes veneer beautifully, costs a fraction of solid oak. 18 mm Mr. grade for side panels, 25 mm for top and bottom caps, which also stiffen the rack against racking forces. Each box pocket screwed together with a 3 millimeter reveal around the frame, so the steel disappears visually but the rack still breathes. Boxes ship flat and assemble on site in 20 minutes each. Oak veneer selection took 3 trips to the timber yard. Needed quarter-sawn white oak with consistent cathedral grain across 12 panels totaling 6 square meters. Match the veneer sequence so grain flows vertically across the full wall height without abrupt shifts at frame joints. 6 mm thick, pressure bonded with urea formaldehyde-free adhesive, finished with 2 coats of water-based matte polyurethane at 12 microns each. Feels like solid wood, but moves as one stable panel. The closed cell foam lining inside each MDF box pulls double duty. Book protector and thermal break. The steel frame conducts cold from the unheated entry zone in January. Cut 90 mm wide strips of 6 mm polyethylene foam and contact cemented them to the MDF interior faces, covering the shelf support rails completely. Books now rest on foam, not steel. Dust jackets never crease. The foam compresses 3 mm under a heavy art book, creating a gentle cradle effect that feels surprisingly luxurious. Shelf rails are standard 19-inch rack mount slides rated for 40 kilos per pair. We derated them to 25 because dynamic loading from pulling a heavy book matters. Each shelf is a 25 mm MDF panel edged with solid oak strip matching the veneer. Slides lock in the open position with a satisfying click. Tested each shelf with 30 kilos of concrete blocks for 24 hours, measured 0. 2 mm deflection, well within the L/360 limit for architectural millwork. Loading 240 books revealed the real capacity. Weighed every box on a luggage scale before shelving. Total book mass, 312 kilos distributed across 24 shelves, averaging 13 kilos per shelf, well under our 25 kilo derated limit. Heaviest shelf holds oversized architecture monographs at 22 kilos and still shows only 0. 3 mm deflection after 6 months. The old Billy would have sagged 15 mm under the same load, according to its spec sheet. Weight comparison surprised us. 6 rack frames plus MDF boxes plus veneer plus hardware, 47 kilos total. A single Billy bookcase of equivalent height weighs 30 kilos empty, but we needed 8 Billies to match the linear shelf meterage, 240 kilos of particle board versus 47 kilos of engineered system. That 193 kilo difference meant we could skip reinforcing the floor joists, which would have added 2 weeks and €3,000. The math drove the design. Living with the wall for 6 months taught us the cable channel gets warm, router and switch, exhaust into a confined space. Drilled 2 12mm vents at top and bottom of the rear tray, creating a passive chimney effect that drops internal temperature by 4 degrees Celsius. The foam lining also dampens the subtle hum of the router fan, which used to resonate through the hollow partition. Now the hallway is quiet enough to hear the radiator tick on cold Ankara nights. Cost breakdown: 1. €800 materials including rack frames, MDF, veneer, foam, slides, hardware, and finish. A local carpenter quoted 4. $500 for a built-in with similar specs but solid oak throughout. We spent 6 weekends of evenings and 2 full Saturdays. Values our labor at roughly 0 if you enjoy the process. The real win: the system adapts. When we need deeper shelves for vinyl records, we just order deeper slides and new MDF panels without touching the structure. The one change for version 2, integrated LED strips in the front flange recess. Current ambient light from the living room leaves lower shelves in shadow after sunset. Tested a warm 2700 K strip at 3 watts per meter tucked behind the oak edging. Throws a beautiful grazing light across the book's spines without glare. Power supply fits in the cable channel, dimmer mounts where the old light switch lived. That upgrade is next autumn's weekend project. What started as a hollow partition became a structural library carrying 300 kilos of books on 47 kilos of engineered frame. The 4mm lean taught us to respect the floor slope. The foam lining taught us that books deserve a soft landing. The cable channel taught us that infrastructure can be beautiful when it follows a standard. 6 rack frames bolted between studs, skinned in oak, now define the hallway not as a passage, but as a room you want to pause in. What started as a hollow partition became a structural library that carries 300 kilograms of books on 47 kilograms of engineered frame. The 4mm lean taught us to respect the floor slope. The foam lining taught us that books deserve a soft landing. The cable channel taught us that infrastructure can be beautiful when it follows a standard. 6 rack frames bolted between studs skinned in oak now define the hallway not as a passage, but as a room you want to pause in. The wall holds its weight, and the books hold their stories, and the hallway finally feels like home.